In an ancient temple, there are 3 needles. On one needle is a stack of 64 golden discs. The largest disc rests on the temple floor, and each disc is smaller than the ones below it up to the top of the stack. The priests in the temple move the discs from one needle to another without stopping, though they cannot move more than one disc at a time and may never rest a larger disc on a smaller one. Once the entire tower has been moved, the tower and the temple will turn to dust and the earth will be destroyed. So how long do we have until the entire earth disappears? At first it seems like we might be in some serious trouble, but let's try to work it out for ourselves. This puzzle is called the Tower of Hanoi. And like a lot of puzzles, it's easier to start by understanding a simpler case and then seeing if we can bring that knowledge with us when we want to solve a harder problem. So let's start out on the blackboard with the simplest version of the puzzle possible. What if we had just one disc on a peg? There's nothing in the way, and all we have to do is pick up the disc and move it over. The solution is going to look like this. I want to keep track of how many moves it takes us to solve the puzzle over here, and we'll talk about why a little bit later. So for one disc, it takes one move. Now let's see if we can figure out how long it takes to move a 2-disc tower. Let's call the top disc A and the bottom disc B. First, let's move disc A out of the way. Then we'll move disc B over to another peg. And then we'll put disc A back on top. This took us 3 moves, so let's write that down. Let's also write out the moves we did to keep track for later. For this solution, we'll write A, B, A. And for the 1-disc solution, we just write the letter A. Now let's try 3 discs. The only thing we can do to start is move disc A. Now, if we want to make any progress, we'll have to move disc B. Now, if we want to move disc C to make any more progress, let's move disc A out of the way. So we'll put it on top of disc B. Now we can move disc C. Wait a second. Now we have to solve the 2-disc problem to get that back on top of disc C. So we should ABA again to get a full stack on another peg. That took us 7 moves. And our order of moves was A, B, A, C, and then we did A, B, A again to get us back to the full stack on one peg. Watch me do the 4-disc puzzle and see if you notice any patterns. So let's take what we know about these solutions and see if we can guess what the solution for the 4-disc tower was. So for the 1-disc tower, it's just one move, it's A. For the 2-disc tower, it's ABA. And then for the 3-disc tower, we did ABA, and then we did C, and then we did ABA again. So we can actually see that every solution is the solution before it, and then one new disc added, and then the solution again. So the solution for D is going to be ABA, C, ABA, and then D, and then ABA, C, ABA again. So in total, that's ABA, C, A, B, A, D, A, B, A, C, A, B, A, or abacaba, dabacaba. And so we can think about this as if we're building a big staircase where we're trying to make it as tall as possible with only a certain number of sizes of blocks. So if you only have one block size, your staircase is going to look like this. You're only going to have A. But if you get access to another block size, then now you can do A, B, A by putting A down, putting your new big block down, and then putting the same staircase from before on top. So for C, we're going to add a big block C, and then we'll put the ABA staircase on top. And for D, we'll do the same thing. And so for either the moves in the towers of Hanoi or in the staircase example, we can see the number of steps that we need is from before we found these were 1, 3, and 7, and now this one is 15. So let's look at those numbers a little bit more. If you don't see the pattern immediately, maybe pause the video and try to figure it out for yourself. But once you've done that, you can come back and you'll see that the pattern is that if we add 1 to each of these numbers, we're going to get powers of 2. So this is 2 to the power of 1, this is 2 to the power of 2, this is 2 to the power of 3, and this is 2 to the power of 4. And so you might guess from this, and you'd be correct, that for a tower with n disks, that the fastest way to solve it would be in 2 to the power of n minus 1 moves. And you'd be correct. And so numbers like this are called Mersenne numbers, and they're very interesting if you want to talk about finding big prime numbers or other things like that. But it's also the number of solutions to a tower of Hanoi with a certain number of disks, or the number of blocks required to make a staircase in the prior example. So these numbers grow really fast because you have this n in the exponent. And so it takes about twice as long to complete the tower for each additional disk you add. So let's talk about the 64 disk tower that we talked about at the beginning. That will take 2 to the 64 minus 1 moves. And that is about 18 quintillion moves. So that's going to take a long time. Let's give the priests the benefit of the doubt and say that they can move 1 disk per second. They're going lightning fast. It's still going to take them 585 billion years to complete the tower, which is about 14 times longer than the universe has existed. And so this might be surprising to you if you're unfamiliar with exponential growth. But if you want to try to get a feel for it yourself, maybe try saying some of the solutions to the puzzle as words. So start by saying ah, and then you could say abba, and then abacaba, and next would be abacaba dabacaba, and see if you can just get to the letter M before you start getting hungry. It's going to take a lot longer than you think, and just going through the letter M, the first half of the alphabet, is going to take a tiny, tiny fraction of how long it would take you to get to the word that would include the letter Z in it. So if you just want to try for yourself, do some of that. Thank you for watching the video. I hope you enjoyed it.